Happy to welcome you to my educational channel Maths Classes 7-8 CBSE by GK Pillai. This is my second video on the chapter Squares and Cubes. Fundamentals of the chapter have been explained very well in my first video. This video you will find, in addition to answers to textbook questions, some more very important practice questions. These questions are exam oriented and will be of much use during your exams. Watch the video fully till the end and also for a second time. This will make you understand the concepts in a clear manner. Don't forget to subscribe to my channel and press the like button. You may also offer your comments in the comments section. You must be knowing by now what is the square of a number, cube of a number, square root and cube root, etc. First of all, square of a number. Numbers obtained by multiplying a number by itself are known as square numbers. You must be knowing about this. A number is a perfect square if its prime factors can be organized into two identical groups. See, when you prime factorize 900, you will get this many factors. But if they can be separated into two identical groups, 3 into 2 into 5, 3 into 2 into 5, then this is a perfect square number. And this is the square root of 900 that you will come to know later. Properties of perfect squares. There are certain useful properties of perfect square numbers. Perfect squares end with the digits 0, 1, 4, 5, 6 or 9. Or it can have even number of zeros only. Maybe 2, maybe 4, etc. These are some examples of square of numbers. And one more thing, a perfect square number cannot end with the digits 2, 3, 7 and 8. Now cube of a number, in the same way as square of a number, numbers obtained when a number is multiplied by itself 3 times are known as cube numbers. These are some of the examples. When you multiply 3 times, 3 into 3 into 3, you get 27, just like that. A number is a perfect cube if its prime factors can be split into 3 identical groups. Just like I said in the case of square numbers. Here 9261 is separated into 3 identical groups and one of the 3 will be the square root also. Now if you can separate it into 3 identical groups, then this will be a cube number and one of the 3 will be the cube root of that particular number. Now square root and cube root. Finding the square root and cube root are the reverse operation or inverse operation of squaring and cubing respectively. If you can find the square root of a number, the inverse operation will be the square root. If 289 is the square of 17, then 17 is the square root of 289. You will be able to write 289 into 17 as 17 into 17 and one of the two will be the square root of 289. Another example, 216. If you prime factorize, you will get 2 into 3, 2 into 3 and 2 into 3. So the cube root of 216 will be 6. Actually, if you are finding the square root, for example, square root of 289 will be plus 17 as well as minus 17. But as far as your syllabus is concerned, you will consider only the positive number. There are certain useful properties of square numbers and cube numbers. These are important because this is the age of MCQs. Certainly, this type of numbers can appear in the MCQ part of your question paper. So it's very important you understand and learn them. Sum of the first n odd numbers is n squared. Sum of the first n odd numbers. If you are writing 10 odd numbers, their sum will be 10 squared 100. There are practical sums also based on this. Nth odd natural number will be 2n minus 1. Suppose you want to find the 10th natural number. It will be 2 into 10 minus 1. That will be 20 minus 9, 119. Every square number can be expressed as the sum of consecutive odd numbers starting from 1. Practically, you will see this one later on. We can find out whether a number is a perfect square by successively subtracting odd numbers. That also you will understand later on. There is a practical question also. Parity of a number and its square. This is a new term you should remember. A number and its square always share the same parity. If a number is even, its square is also even. If the number is odd, its square also will be odd. 5 is an odd number, square will be 25, which is also an odd number. 8 is a even number, 8 squared will be 64, that is also even number only. Now we will continue with that. Square of a number can only have an even number of zeros at the end. You must be knowing. Squares and cubes of even numbers are even. Squares and cubes of odd numbers are odd. A perfect square can always be expressed as the product of pairs of prime factors. This is a very normal thing. A perfect cube can always be expressed as the product of triplets of prime factors. Perfect cube. That's what I have shown just now. Here I am giving just for making it useful during your exams for answering the MCQ questions. There are 2n natural numbers between the squares of numbers n and n plus 1. For example, between 20 squared and 21 squared, there will be 2 into 20, 40 natural numbers will be there. These questions are from Find It Out category of questions from page number 10 of your textbook. The first one, which of the following numbers are not perfect squares? One thing you can see, these numbers 1, 2, 3, these numbers are ending with the numbers 2, 8 and 7. These are definitely not perfect squares. Now let us come to this number. Looking at this number, you can say this is a square number, but let us prime factorize and confirm. When you prime factorize this number, you will get 11, 11, 3 and 3. So naturally 1089 is the perfect square number and the remaining are not perfect squares. You don't have to write this one. You can write only it is, but these numbers are not perfect squares. Which one among 64 squared, 108 squared and these two has last digit 4? Here 8 into 8 64, 4 will be there in the last digit in the units place, and 2 into 2 4. So only these two numbers will have the last digit 4. Given 125 squared equal to 15625, what is the value of 126 squared? The answer is here 1515625 plus 251. This is the answer. How you are getting this 251, I will be explaining you in another question. Question number 4. Find the length of the side of a square whose area is 441 meters squared. You may get in your exam, instead of 441, you may get many other different values. So you should be knowing how to find the square root of numbers. It will be always better you remember the square of numbers up to 30 at least minimum. Area of the square 441 meters squared. Side of the square will be the square root of that will be 21 meter. By prime factorizing, otherwise you can remember what is the square root of 441. Find the smallest square number that is divisible by each of the following numbers 4, 9 and 10. First of all, we will find the solution of, we will find the LCM of these numbers, that will come to 180. You have to prime factorize this to get the factors. 2 into 2 into 3 into 3 into 5. 5 is missing. So 180 into 5, 900, and this is the smallest square number divisible by the numbers 4, 9 and 10. Another question. These questions are very important for your exams. Find the smallest number by which 9408 must be multiplied. It may be divided also, so that the product is a perfect square. Find the square root of the product. 9408, if you prime factorize, you will get this many factors. Here 2 is in 2, 2 and 2, these are in pairs. 7 is in pairs and 3 is not. So 9408 must be multiplied by 3 to get a perfect square number. So 9408 will be into 3 will be 28224. Write like this. And for getting the square root, take 1 2 from here, another here, another here, and another 7 from here. And 3 means we are multiplied by 3. So once again you can take one more 3. So when you multiply all these things, you will get 168. This is the square root of 28224. Now how many numbers lie between the squares of the following numbers? 16 and 17, 99 and 100. Between 16 square and 17 squared, there are 16 into 2, 32 numbers are there. Between 99 and 100, between 99 square and 100 squared, there are 2 into 99, 198 numbers are there. Question number 8. In the following pattern, fill in the missing numbers. 3 squared plus 4 squared plus 12 squared. 3 into 4, 12. 12 squared equal to, after 12, the next number, 13 squared. See here, 4 squared plus 5 squared plus 4 into 5, 20 squared. And the next one, 21 squared, the missing number. Here again, 9 squared plus 10 squared. 9 into 10, 90 squared, and the next one will be 91 squared. If you calculate and see, you will get the perfect answer only. How many tiny squares are there in the following picture, in the picture given in the textbook? Write the prime factorization of the number of tiny squares. There are 81 squares are there. There are 81 squares, and the prime factorization is 3 into 3 into 3 into 3. Again, find it out on page number 16. Find the cube roots of 27,000 and 10,648. 27,000, if you prime factorize, you will get this many factors. And the cube root of 27,000 will be, out of 3 3's, you will take 1 3. Out of 3 5's, you will take 1 5. And out of 3 2's, you will take 1. So 3 into 5 into 2 will be the cube root of 27,000, that is 30. 10648, prime factorize, you will get 3 2's and 3 11. So 2 into 11 will be the cube root of this number. Now the next one, what number will you multiply this one to make it a perfect cube? Just like the square number, here it is cube. 1323, when you prime factorize, you are getting 3 into 3 into 3 into 7 into 7. There should be 3 7's. So we will multiply this number by 7 so that the resulting number will be a perfect cube. The next one, true or false. The cube of a number of any odd number is even? No. There is no perfect cube that ends with 8. That is false. Because even 12, if you take 12, the cube will have 8 in the units place. The cube of a 2-digit number may be a 3-digit number. No. 2-digit number, the cube of a 2-digit number may have 7 or 7 digits. That is also false. And cube numbers have an odd number of factors. That is also false. I have taken two questions from within the textbook. These are a certain type of questions given in the textbook. How many cubes of side 1 centimeter will make a cube of side 3 centimeter? In the mensuration part, you get this type of questions. Volume of cube with side 3 centimeter will be a cube, or 3 into 3 into 3, 27. And the volume of the small cubes of side 1 centimeter will be 1 cube and 1. So the number of cubes that can be made or that is required will be 27 divided by 1, 27. There can be 27 cubes. Given that 45 squared is 2025, find the value of 46 squared. This is what I mentioned before, how to get the final answer. To find 46 squared, we need to add the 46th odd number to 2025, and 2025 is the sum of the first 45 odd numbers. When it is 45 squared, you must be knowing 2025 is the sum of the first 45 odd numbers. This is what I explained before also. Now to find the 46 squared, we have to add the 46th odd number to this one. So the formula to find the nth odd number will be 2n minus 1. So the 46th odd number will be 2 into 46 minus 1, that is 91. We will add 2025 and 91 to get the value. This is the square of 46 squared. Let me explain you once again. 45 squared is 2025. You have to find the value of 46 squared. We know that 2025 is the sum of the first 45 odd numbers. And 46, for finding 46 squared, we will find the 46th odd number and add with this. Nth odd number will be 2n minus 1. So 46th odd number will be 2 into 46 minus 1. That will be 91. We will add 91 with 2025. That is 2116. This is the square of 46 square. Square of the number 46. So you should be knowing this type of sums. These are some extra questions for practice. Check whether the following numbers are perfect squares. So these numbers are ending with 7, 8 and 3. Therefore these are not perfect square numbers. Which of the following numbers would have 1 at the digit 1 at the units place? Here 9 9s are 81, 1 1s are 1. So these two numbers will have 1 at the units place. How many natural numbers lie between 1000 squared and 1001 squared? There are 2 into 1000, 2000. I am repeating some of the questions because these are very important as far as your MCQs are concerned and also for 1 mark questions. Without adding, find the sum. Here you will find 12 odd numbers being added. So 12 squared 144 will be the sum of these numbers. Express 225 as the sum of 15 odd numbers. It is almost the same sum. You keep on writing odd numbers from 1. When you reach 15, the sum will be 225 only. Find the smallest square number which is divisible by each of the numbers 8, 15 and 20. Just like another sum which I discussed earlier, find the LCM of these numbers, that will be 120. This sum is bit different from that. That is the idea of giving a repeated sum. 120, when you prime factorize, you will get this many factors. 2 into 2 is okay, but 2, 3 and 5, these are not in pairs. So we will multiply 120 by another 2, another 3 and another 5. So you will get 3600, and this is the smallest square number divisible by 8, 15 as well as 20. Now it's also another sum identical to this one. Find the square root of 121 by repeated subtraction. These are all related sums only. 121, start subtracting from by the odd number starting with 1. 1, 3, 5, etc. 121 minus 1, 120, 120 minus 3, 117, and continue with that till the time you reach 0. So by repeated subtraction we have shown that the square root of 121 is 11, because 11 times you have subtracted odd numbers. Let me continue with the practice questions. Find the smallest whole number by which the following numbers are multiplied to get a perfect square number: 2925 and 2645. When you prime factorize 2925, you get this many numbers. 13 is not in pairs, so 2925 must be multiplied by 13 to make it a perfect square. You don't have to multiply and show. 2645, by prime factorization we get 5 into 23 into 23. So naturally 2645 must be multiplied by 5 to make it a perfect square. Question number 9. Find the smallest whole number by which the following numbers are divided to get a perfect square number: 1008 and 2028. When you prime factorize 1008, we get this many factors, but see 7 is not in a pair, so 1008 must be divided by 7 to make it a perfect square. There it is multiplied, here it is divided. 2028, when you prime factorize, you get these factors. Here 3. So 2028 must be divided by 3 to make it a perfect square. Finding the square root of a number by the long division method may not be there in your textbook. But this type of finding the square root is very important, not only for this chapter, even for other chapters also it is very important. Even for the mensuration chapter, finding the square root of a large number, you can definitely use this one if you can understand this. Find the square root using the long division method. 4096, what you have to do? You have to separate it into, identify into two groups in pairs, 40 and 96. Now 40, 6 are 36. You have to count that way and decide any number which is less than 40. 6 are 36. Subtract, you will get 4. Now multiply this 6 by 2 and write here 12. You can place any number here and multiply the whole number by that particular number. 6 into 2, 12. I am placing 4 here. 124, when I am multiplying by 4, I get 496. So it is 0. 64 is the square root of 4096. Another one, here there are 5 digits. Then you have to separate this 1, then 5 1 separate and 2 9 separate. 1 ones are 1. I write here 1, here also I write 1. Subtract, I get 0. Now you bring 2 terms down, 51. Multiply this 1 by 2 and write here, and put any number here and multiply this, multiply the whole thing by this 2. 22 multiplied by 2, 44, and this should be less than, definitely less than 51 and closer to 51. Subtract this, I get 7. Bring this 29 down, 729. Same time multiply again this 12 by 2 and write here, and put any number and multiply by the same number. 243 multiplied by 3, I am getting 729, 0. So 129 is the square root of 15129. Again 7921. 8 8s are 64, I am writing here. Subtract, I am getting 15. Bring this 21 down. It should be in pairs. 8 into 2, 16, I am writing here. I am writing 9 in the bracket. 169. If I multiply by 9, I get 1521 and 0. So 89 is the square root of 7921. And this is a decimal number. 51.84. 7 sevens are 49. I am writing here. 2 down. 49, 51 minus 49. And I have to bring 84 down. There is no need to put the decimal place here. But here you should definitely put the decimal place. So 7 2s are 14. And 2 I am putting in bracket. 142 multiplied by 2, I get 284. 284 minus 284 will be 0. That means the square root of 51.84 is 7.2. Find the cube root of each of the following numbers by prime factorization method. You find the prime factors. Out of 3 2's, you take 1 2 and like that. So you will get 1 2 from here, 1 2 from here, and 1 2 from here. 2 into 2 into 2, 8 will be the cube root of this. Similarly, you can do the rest of the sums. 10648. If you prime factorize, you will get like this. 2 into 11, 22 is the cube root of this. 15625. This many 5's are there. The cube root will have 2 5's. 25 will be the cube root of this. 13824. Prime factorize, you get this many 2's and this many 3's. If you take 1 2 out of 3 2's, you will get like this. 2 into 2 into 2 into 3. 24 will be the cube root of 1 3 8 2 and 4. These are actually some special sums. Definitely these are bit difficult, but some of the schools can definitely ask this type of questions. These are typically different and these are very important also. Very important. I mean, it's very important. Given that the value of under roots 5625 is 75, find the value of 56.25 and square root of 0.5625. See, if the square root of 5625 is 75, the square root of 56.25 will be 7.5. And the square root of 0.5625 will be 0.75. That's what I have written here. So 7.5 plus 0.75, 8.25 will be the square root of, will be the value of this much. Next one, evaluate. This is not very difficult. You have to find the cube root of these numbers, but these are in decimals. 27 is okay, 3. See, 0.2. 0.2, when you multiply 3 times, you will get 0.008. 0.4, when you multiply 3 times, you will get 0.00064. So the cube root of this number will be 0.4. Add them, you will get 3.06. See, there is a question like this. Find the value of this. There is a square root here, another square root here, another square root. The third one will be a perfect square. 144, the square root is 12. Now within this under root, you write 52 plus 12, 64, and the square root of 64 will be 8 right here. Now you add 8 with 248, you will get 256. This is a perfect square number, 16. So the value of this one is 16. How we could find this one, you should be definitely working out and try to understand. Here there are two sums. Find the length of each side of a cube of volume 512 centimeter cube. I have already told you one sum about finding the side of a square. This is a cube. So naturally, when you are given the volume, find the cube root of that number, maybe by prime factorization only. You will get the answer to be 8 centimeter. The next one, find the side of a square whose area is equal to the area of the rectangle with sides this and this. Multiply these two, length into breadth. Area of a rectangle is length into breadth. Multiply, you will get 16 centimeters squared as the area of the rectangle. Now area of the rectangle and the area of the square is the same. So naturally the area of the square will be 16 centimeters squared. Side will be the square root of 16, 4 centimeter. Another important sum. Three numbers are in the ratio 2:3:5. If the sum of squares of these numbers is 608, find them. Let the three numbers be 2x, 3x and 5x. Sum of the squares is given as 608. So 2x whole squared plus 3x whole squared plus 5x whole squared will be this much. This is 4x squared, 9x squared and 25x squared is 608. Add them. You will get 38x squared to be 608. X squared will be 608 divided by this 38. You will get 16. Square root of 16 will be the value of x, 4. Now the numbers will be 2 into 4, 8, 3 into 4, 12 and 5 into 4, 20. Two more sums. A hall has a capacity of 2704 seats. If the number of rows is equal to the number of seats in each row, then find the number of seats in each row. One thing I can tell you for sure, when you will be writing an exam or when you will be learning from your school teacher, definitely you will remember me, because this type of sums are often asked in your school and school exams, like that. Number of seats 2704, number of rows equal to number of seats. So what we will do, we will find the square root of 2704, that will be 52 by prime factorization, or the way I explained in a pre-page. Number of seats in each row and also the number of seats and number of rows will be 2704 only. Another one, 2025 plants are to be planted in a garden in such a way that each row contains as many plants as in the number of rows. Find the number of rows and the number of plants in each row. So we will find the square root of this one only. Number of rows equal to number of plants in each row. Square root of 2025 will be 45. So both the answers, number of rows as well as number of plants in each row, will be 45. That is the end of my present video. You can watch this once again to understand it in a better way, and also during your just before your exam also you can watch this video again. That will be very useful for your exam.